Welcome back. Lesson 9 Functions. Introduction. Definition. Let A and B be non-empty sets. A function f from A to B is an assignment of exactly one element of B to each element of A. We write fa equals B if B is the unique element of B assigned by the function f to the element A of capital A. If f is a function from A to B, we write f from A to B. Think of a function as an airline which takes passengers to their destinations. While several passengers may go to the same destination, one passenger cannot go to several destinations. Also, no passenger should be left behind, while it's perfectly fine for a destination to have no passenger visited. Functions are sometimes also called mappings or transformations. We may also view a function as a relation, that is a subset of A cross B, such that for each A in capital A there exists a unique AB in R. Here is how we visually represent a function. Okay. A little a is being taken to little b. So you write it b equals f of a. F is the function from set A to set B. If f is a function from capital A to capital B, we say that the left-hand side set A is the domain of f and B, this set, is the codomain of f. If f of little a equals little b, we say that b is the image of little a and that a is the pre-image of little b. The range or image of function f is the set of all images of elements of A. When f is a function from A to B, we say that f maps A to B. This is a lot of information, guys. I hope it's clear. So, little a goes to B. Little b is therefore called image of A under F. You collect all those elements which are actually images. That entire set, subset of B, is called range or image. Okay. Two functions are said to be equal when they have the same domain, have the same codomain, and map each element of their common domain to the same element in the common codomain. Suppose we ask each student in this classroom to state their height in inches at this very moment. Is this a function? Well, each student is asked to state their height in inches at this very moment. Yes, this is a function because every student has a height. Moreover, every student has a unique height. That's why it's important to say at this very moment. You know, as your age changes, your height changes. In fact, height even changes a little bit within time of the day, within a day. So, but if you are checking your height right now at this moment, every student will have a unique height. That is a function. What is the domain? Domain is the set of all students in our classroom. What is codomain? Well, your height cannot really be 0, but it will be positive numbers, right? So we are stating our height in inches. So let's say positive real numbers. What is the range of this function? Well, am I going to get a student with height, I don't know, 10,000 inches? No, I'm not going to. So range is going to be a proper subset of all the heights as numbers I get from my class. That's it. Okay. Suppose, here is another example. Suppose we assign to each living person on this earth to their biological mother. Is this a function? Well, every person has a biological mother and every person has a unique biological mother. All right. So this is indeed a function. What is the domain? Domain is the set of all human beings currently living on earth. What is codomain? Well, mothers are women. So codomain is the set of all women. What is the range? Well, notice some mothers have already died, you see. So your codomain does not require that all the women be living. Some of them have died. What's the range? Range of this function is the set of those women who are biological mothers, right? Of somebody who is presently living. Now, suppose we assign to each living woman her child. Is this a function? No, it is not a function. A woman can have more than one biological children. That means you don't have a unique child. So this is not a function. Consider the function consider the mapping f from real set of real numbers to the set of real numbers. The assignment is given by f of x equals x power 2. Is this a function? Yes, it is a function. Because for every x, every real number x, x to the power 2 is uniquely defined. What's the domain of this function? Well, every real number can be squared. So domain is the set of real numbers. What's the codomain? Well, codomain is the set of real numbers as listed. What's the range? Well, square of a real number is either 0 or positive. So the range cannot be negative. So range of this function is the set of all non-negative real numbers. Now, consider the mapping f from the set of real numbers to the set of real numbers. An assignment given by f of x equals square root x. Is this a function? No, as stated, it is not a function because negative numbers, if I take square root, I don't land in real numbers. I land in complex numbers. So this is not a function. Okay. We say that a function is integer valued if its codomain is the set of integers. Function is integer valued if it lands in integers, in the set of integers. We say that a function is real valued if the codomain is the set of real numbers. Two integer valued or two real valued functions may be added or multiplied. So you take two functions, say f and f1 and f2 from a set A to the set of real numbers. Then I can add them and I can multiply these two functions. f1 plus f2 on some input A, on every input A, x, f is equal f1x plus f2x. Likewise, f1 times f2 on x is f1x times f2x. Define two real valued functions f1 and f2 and find their sum and product. So let's do that. Let A be the set of integers. Okay. And let f sub 1 be a function which from integers to the set of real numbers. All right. Likewise, f2 also be a function from the set of real integers to real numbers. How do we define these, right? Suppose f sub 1 on any integer a is 2a, and suppose f sub 2 on any integer a is a to the power 2 minus 3. All right. So this is how we define f1 and f2 for all a in the set of integers. Okay. All right. Wrote this neatly. Then what is f sub 1 plus f sub 2 on any number, any integer a? Well, it will therefore be simply addition of these two rules. 2a plus a to the second minus 3. What is f sub 1 times f sub 2 on any integer a? It is 2a times a squared minus 3. All right. This is the case for all integers a. All right. Okay, so this is an example of how you would add or multiply two real valued functions.